community update for June 6th. So we have the Kubernetes birthday coming up. So there's lots of events going on this week. We have people taking over the Twitter feed and so on. Before we get into the updates and demos for the week, just a reminder that we are following the CNCF Code of Conduct. So please be respectful to everyone else on the call. All right. First off, we have a demo of KubeOne to demonstrate lifecycle management for high availability Kubernetes clusters.
Hello, everyone. Thanks for the introduction. Today, we will see KubeOne, a tool for cluster lifecycle management. I am Marko Modrovic, a software developer at Lucy and a computer science student at the University of Belgrade. You can find me on Twitter, GitHub, and Kubernetes Slack as xmodri. So, what is KubeOne? KubeOne is an open source tool for managing Kubernetes cluster lifecycle. It installs and provisions Kubernetes, upgrades to a newer, minor or patch release, and unprovisions the cluster. By unprovisioning, that means undoing the work done by KubeOne, like destroying working nodes, unprovisioning Kubernetes itself, and removing Kubernetes binaries. KubeOne works on the most popular cloud providers, on-premises, and on bare metal. It is focused on highly available cluster, supporting Kubernetes 1.30 and newer. We are often asked why we built KubeOne when we have so many awesome tools handling cluster lifecycle. And one of the reasons is that Kubernetes brought us a new way for managing our workload. We are doing in a cloud-native, decorative way, but managing Kubernetes clusters can still be a hard task. So we wanted to apply some of the lessons learned managing workload to cluster. And in a search for a feature-complete solutions, we decide to build KubeOne. KubeOne uses the latest technologies to bring many features in an easy-to-consume manner, like kubeadm, Kubernetes Machine Controller, which is open source cluster API implementation, as well as cluster API itself. KubeOne brings decorative cluster representation. All clusters are represented in a form of a configuration manifest. Such configuration manifests can be used to create clusters and many similar clusters, so you can easily reproduce. Then you can share cluster manifests with your colleagues in version control systems and more. When KubeOne provisions the cluster, it is ready to use. We deploy the CNI plugin, and there is a choice between kernel, which is basically Flannel plus Calico, and VNet, which supports some advanced features such as encryption. KubeOne can optionally configure many features like pod security policy, dynamic audit log backend, metric server, and more. Besides that, it is possible to integrate KubeOne with infrastructure provisioning tools like Terraform, Ansible, CloudFormation, and out of box, there is integration for Terraform, so you can source Terraform state to learn on what instances Kubernetes will be installed and configured. KubeOne is supposed to work on any provider, including on-premises and on bare metal. But officially supported providers enjoy additional features, such as support for managing working nodes using Kubernetes Machine Controller, automatically deploy cloud provider-specific features like external cloud controller manager, or if there's additional configuration needed for such cloud provider, as well as to use Terraform integration to source information about infrastructure from the state. Officially supported providers for now include AWS, GCE, DigitalOcean, Hasser, Packet, OpenStack, and VMware vSphere. Microsoft Azure will be supported as of the upcoming 0.9 release. So how it works, how you can use KubeOne? The first step is to create instances and infrastructure to be used by Kubernetes. KubeOne comes with example Terraform scripts that can be used to get started and create the needed infrastructure. Then you need to build KubeOne configuration manifest, which describes the desired cluster, like what Kubernetes version will be installed, what machines will be used, how the cluster will be provisioned, what features will be activated and configured, and more. Then just run KubeOne install and enjoy your cluster. So let's see the first step, and this is building KubeOne cluster manifest. Now, on the left side, we have a minimal manifest that you can use if you use Terraform integration. At the top of it, we have API version and guide, like for any other Kubernetes style manifest. Then we define version, and we define that we are going to deploy on AVS, for example. Such manifest you can deploy using KubeOne, install, config YAML, and then provide the Terraform output, which is in this example called tf.json. Such output is generated using Terraform output command, and it is important to know that to use such integration, it is required to follow the template used by KubeOne, and you can find it in each example. Example Terraform script. But if you don't want to use Terraform, you can use any other tool, but you're going to need to provide information about host and the API endpoint yourself, like public addresses. Now, the output is a little bit cut, so it can fit on slides, but there's much more like private addresses, then SSH information, and more. Such manifest is just applied using KubeOne install and bit applied to the config manifest. Now, let's switch to the demo. I have recorded a quick ASCII demo that is going to show how it works and how you can use KubeOne. This is because the provisioning process takes like between 5 and 10 minutes, depending on the cloud provider or the environment. So we don't have time to show it now, but this is a little bit speed up so you can still see it. The first thing we do is to provision the infrastructure. We set some Terraform parameters like number of control plane nodes, cluster name, and more. We run Terraform plan to see are all changes okay, then Terraform apply. It usually takes several minutes, and after it is done, it will output the Terraform output that we export using Terraform output command based on this template defined in output.ef file. As mentioned, it is important to follow this template if you use Terraform integration. Now that we have Terraform output, we create the config manifest, which is very similar to the one we showed. This example uses DigitalOcean, and we run KubeOne install config YAML with tf.json. It determines the operating system and everything needed, generates kubeadm configuration file, certificate needed for AJ cluster, then synchronize between control plane nodes, then run kubeadm, init and kubeadm join to join control plane nodes, and then deploy CNI, machine controller, and create working nodes. To be able to use the cluster, you need to export the kubeconfig environment variable. Kubeconfig file is downloaded automatically. It takes some time for nodes to appear. They're handled by Kubernetes machine controller. And this works like, as this is cluster API implementation, working nodes are backed by the machine deployment object, which works like deployment object. It will create machine set and machines, and then on instances in the cloud. But what is important here is that you can use kubectl to manage your working nodes, create a new ones, edit existing one, like you can edit to upgrade them. Also, KubeOne upgrade command is taking care of that automatically. You can increase and decrease number of nodes. Here we use kubectl scale command that increases the number of replicas first to 5. After some time, new replicas will appear. But you can also say something like replica 0, so you delete all working nodes in that machine deployment. If you want to learn more about machine controller, you can find it in Kubernetes repository. But also, if you want to learn more about cluster API itself, there is a cluster API repository in the Kubernetes 6 organization. Also, they have a very nice guidebook that you can take a look at it and learn more about it. So, for the ending, I want to thank everyone who came today. Oh, sorry. You can find KubeOne on GitHub in the Kubernetes organization. You can follow me on Twitter, xmoody, and follow Lucy for updates about KubeOne, blog post. We have a more detailed announcement blog post that describes KubeOne in some more details. Also, last week we have done a CNCF webinar, which shows how KubeOne works in detail. And also, we have a Slack on Kubernetes Slack, and you can find here a link to join. If you want to join KubeOne channel, ask questions, or chat. You can also send us a question to me on Kubernetes Slack, on GitHub, or wherever you prefer. Thank you so much for joining today.
Cool. Thank you for that demo. I think I know a couple people who would be interested in that tool. Do we have any questions? All right, going once, going twice. All right, next up, we have Claire Lawrence from the 1.15 release team here to give us an update about the release cycle.
Yes, hello everyone. So we are nearing the end of week 9 of our release cycle. So things that happened this week, we have our docs PR review milestone, and we're hoping to make sure that all of the review is going to be done by June 10th of next week. So all the docs PRs came in on Tuesday. And then we also cut our second beta yesterday. And then coming up next week, we'll be cutting our first RC on June 11th. We're also planning to have code thought on June 11th. And then June 13th will be the cherry pick deadline. And then very, very soon, coming up on June 17th, is the target release date for 1.15. So we are nearing the end of things. The current release status is yellow right now, mostly because we have 3 open issues that Bug Triage is working through that there's a little bit of debate going on the PRs if they're going to be in the 1.15 release or not. So we're hoping to get those 3 issues resolved. And then we also have some yellow coloring coming from our comms team because they're still trying to finalize some of the themes for the release, which they want to try to get done by the end of day tomorrow before the weekend. Though if they're able to get those themes done, then they're going to start trending green. So that would be good. Additionally, for 1.16, we've started pushing everyone to think about secession. I've nominated Lachlan Evanson to be the 1.16 release lead, and he's accepted. So he will be the release lead for the 1.16 release. So everyone look forward to hearing him give the updates every single week at the community call instead of myself. And I think those are all my major updates. Any questions about the release?
Do we have any patches that we should be watching for?
I do not know, as I'm not super closely plugged in with the patch team, but possibly we can ask over in #SIG_release in Slack, and one of the patch managers should be able to chime in there. Or if any of the patch managers are on the call, they might be able to answer that.
Cool, thank you. All right, heading on, we don't have a contributor tip of the week, unfortunately. There was a last minute snag with some of our data. I don't also see a KEP of the week, so you're spared that. Moving on to SIG updates, we have first off a update from SIG multi-cluster. So are we ready to roll that?
Yes, and I generously thank you in advance, Valerie, for agreeing to see if you could share the deck for me, since I'm having some technical difficulties.
I pawned it off to George because he's the stream expert, but looks like
excellent delegation. You're clearly heading places. Okay, so hey everybody, I'm Paul. I am one of the chairs of SIG multi-cluster, and this is our multi-cluster SIG update. And I can no longer see the deck. There we go. George, would you mind advancing the deck 1 slide?
One second, I'm having some technical issues myself here.
It happens to the best of us, is what I've heard.
All right, how's that?
That'll work. Would you advance it a slide? All right.
I don't know about anybody else, but I'm only seeing about a third of the slide.
Yeah, it's a little bit cut off.
There you go.
Oh, there we are.
And now you're muted, Paul.
You are correct. I am muted. Thank you. So there's two main efforts that I'm giving an update on today. I'll start with the second one first, which is cluster identity. This is a very recently started effort to develop a concept of a cluster identifier that is more durable than, say, the addresses of the cluster's API endpoints, the certificates that the cluster may use, etc. These are, as I said, just getting started. The current state that it is in right now is that there's a proposal for, these are the things to agree on about this problem, which Adrian from Google has generously written up. I realized shortly before it was my turn to speak that I don't have a link to this in the document, but I will make sure that a link is plumbed into that. The discussion on that is happening in the SIG multi-cluster meetings, which are every other Tuesday. And there's a link to more specific information about that on our SIGs page under community. Secondly, the other project that I'm giving an update on today is called KubeFed. You may have previously heard of this project with the name Federation V2. We've recently renamed it, and if you could advance the slide, that would be great, George. And maybe another one, because that's not a, oh, there we go, already covered that one. How about one more? So KubeFed's goal is to coordinate the configuration of multiple clusters from a single API surface using an active reconciliation approach. And the goal for all of that is to be one of potentially multiple useful building blocks to build higher level use cases like multi-geo apps or disaster recovery that happens across clusters. If we could advance the slide one more. So we're in a state where we have an initial release candidate for our first beta release. We're currently working through some API mechanics around how upgrades will work. But our plan is to have an initial beta release soon with potentially a GA later this year. If we could advance one more. In our last cycle, since we last gave a SIG update, we've done a fairly significant overhaul of the API. In the sense of the current API is far simpler. To summarize it very briefly, one of the fundamental operations of KubeFed is to enable the federation capability for an arbitrary API resource, whether that is part of the Kubernetes API proper or a CRD that you've created that you want to spread to multiple clusters. In the scheme for how we did that, at the point where we gave the last SIG update, you would run this enable operation and you'd get 3 different API resources that captured the different dimensions of what's the essential definition of a resource that I'd like to spread, where does it go, and how may I want it to be differentiated from that essential definition in a particular cluster. We now have this all expressed in a single API resource. There's a CLI command that automates this enablement for you, and also a CLI command that will convert normal resources into their federation equivalents. And if we could advance one slide, I'll say what I think is probably the most exciting thing that we've done in the last cycle is that as we've collapsed these different API resources that represent the different elements of the federation API into a single one, we've also done a lot of work to make the status of that single API resource meaningful and useful to you. So to just talk through a quick example, say that I would like to spread Kubernetes deployment resources over multiple clusters. I would enable that capability for deployments, and that would give me a new API surface called federated deployment. And I can use that API surface to say, here's the essential definition of a deployment I'd like to spread. I want it to go to clusters A, B, and C. And in cluster C, I would like to have 10 replicas instead of 5. What you're able to see now in the status of that federated deployment resources, exactly where has it been deployed to? Are there any problems propagating the resource, et cetera? And then finally, also very exciting to me as someone that wants APIs in Kubernetes to work like one another, we've also done a lot of work to make the API surface both that configures KubeFed and also that's generated by KubeFed more compliant with the Kubernetes API conventions. How about the next slide? In our upcoming cycle, I foresee us doing more work to ease the barrier to entry and make adoption of the KubeFed tool to try it out, to use it, etc., even lower than it is today. And at that point, or after the point of our initial beta release, I think that we'll also be in a position to develop higher level APIs as part of that mission to be useful for more interesting things like multi-geo apps or automated failover across clusters. There's also, I think, an interest in exploring pull reconciliation, which would be more compatible with a GitOps type of model. That's certainly very popular in the community and in general in this industry. Next slide, please. So how can you contribute? We would love to have additional contributors. The project is under Kubernetes SIGs under the name KubeFed. We are especially interested in folks that may have an interest trying it out and giving us feedback, as that's the best time to get that is before you take an API to beta. And our maintainers are interested in providing mentorship. So please do check us out. The work on KubeFed is happening in the KubeFed working group, which meets every Wednesday. And again, there is more specific information about that on our SIGs page. So I think I will end it there. Thank you very much. And let me know if there are any questions.
Cool, thanks, Paul. I have a confession to make. I actually ran production traffic on Federation V1 back in 2017. Looks like things have come a very long way since then.
Yeah, that's very interesting to know, and I'd be very curious to know how you felt about KubeFed, and just a note on that, since things certainly have come a long way for Kubernetes, is that I'll point out, since I think a lot of folks may have familiarity with that old V1 Federation, that we live in a very different world now, where so much of the value proposition of Kubernetes beyond the basic things that you get is the ability that you have to define your own APIs. So I would say that we're especially interested in experiences folks may have using KubeFed with their own CRD-based APIs. And I'm a terrible writhing mass of ears for any feedback people may want to offer.
All right, do we have any questions for Paul? Going once, going twice. Okay, next up we have our regular SIG update for SIG Windows from Patrick.
All right, thank you, Valerie. So now I'm screen share over here.
You're coming in a little quiet, Patrick.
Okay, is this a little bit better?
Yeah.
All right, no problem. All right. Well, thanks everyone. So I'm Patrick Lang. I'm one of the co-chairs for SIG Windows. Um, our other chair, Michael's also on the call as well. Um, but I'll give a quick update of where we're at. There we go. Now my browser works. All right. So looking back, 1.14 was the first release where we graduated Windows Node support to stable, and that was really, pretty much a big culmination of a large stability effort. So that way we could get everything in a good supportable state and make sure that we were keeping things working consistent going forward. So for 1.15, we were focusing on some of the top feedback we had from early adopters, and a lot of that was around sort of making things a bit easier to set up, and then starting to fill some small feature gaps around being able to better support both Windows workloads as well as fixing a few rough edges in the Kubernetes admin experience. Um, so the first thing that we were working on was support for using KubeADM to be able to join Windows nodes to an existing cluster. I'll actually give some more details and a short demo of that in a minute. And then the other thing that we did was there's for customers that are using um, Windows Active Directory for basically providing an identity between an application and another service. An example would be if they wrote something in .NET and they want to connect to a SQL database, they were frequently using what's called a managed service account. And so we had an alpha annotation available for that, but for version 15, we went through the API review process and we actually created a new Windows security context options that's available there under the container spec within the Kubernetes API. The first field we added in there was the one needed to enable group managed service accounts. And then the next one that we're currently finishing up is being able to run as a particular user name within the Windows container. This is a bit different from Linux because in Linux, you always use the UID and GID. Windows doesn't have those. The name is actually converted to a binary identifier behind the scenes. And so we're implementing that. So that way, if you've got a container that's got, a non-privileged user plus a privileged account, then you can correctly create and exec things as those users. The other thing is we had a great contribution from Ben, from Ben Moss. But one of the things we realized was that the way Kube Control port forward was working, it was actually using a streaming operation that was actually using NSEnter and SOCAT, which was, those are both Linux specific concepts. And so we found a workaround where we could make something that was like SOCAT. Ben called it WinCat, but that lets us actually start a port forwarding a little daemon inside the pod. So that way we can use the kube control port forward command going forward in 15. And so we'll be updating the pause image, but that's something that we'd love to hear feedback on for if it's working for Windows developers. And then beyond that, we've been starting to work at how we can take advantage of some of the network updates that are there in Windows Server 1903. And there's been some improvements around direct server return. So that way we can get both better performance, but also do things like preserve source IPs in a way that's more similar with the way they're working on Linux. And then kind of the last, really big effort that a lot of people aren't aware of is that Claudio's been super active over in the conformance working group, working with John and some others there. And what they're trying to do is reduce the number of images that are needed in an end-to-end and conformance test pass, and make sure that that we've got a pass to get all those built as multi-arc images. So this is going to make it much, much easier to be able to run conformance on ARM and also on Windows workloads in the future, and also speed up the conformance passes in general, because they're already shaving off, gigabytes of images that need to be downloaded. So that's something that we'll be seeing a lot of benefits coming from soon. Okay, so right at the beginning of 15, we spent a lot of time between SIG Windows and SIG cluster lifecycle, sort of figuring out, what was the most important things that we needed to change in KubeADM without fundamentally changing the design. And so Kalia and Ben from SIG Windows and Lubomir from SIG Cluster Lifecycle spent a lot of time iterating on designs, and they basically got down to just a couple really narrow changes that were needed in order to allow KubeADM to both discover that it was running on a Windows node, so it could detect the right CRI and get the path to that, as well as work with the Windows init system to make sure that the right dependent services were started. And so that fits the initial goal of KubeADM, focusing on just basically bootstrapping and joining the kubelet to the existing deployment that was run with KubeADM init. So just to give you a quick demo here, I've got a couple of VMs running on my laptop here, but I've got currently two Linux nodes running, and those are both running on CentOS. But what I want to do here is actually go ahead and get a new KubeADM join token. So I've got that, and oh gosh, go away, kitty. Sorry, kitty's stealing stuff off my desk. So going over to the Windows node, I can run exactly the same commands to go ahead and run that. And so it's still using KubeADM. It's run the pre-flight checks, and then now that that's finished running, it's done all the same things it would have done on a Linux node. Including getting the kubelet up and running. So if I go back here and do kube control, git node, now we can see that in addition to the two Linux nodes that were already there, we've got the Windows node there. There's still a couple things that we're working out for on the installation experience though, and that's why that node is not ready. So the next thing that we need to work on is sort of finishing up how we're doing CNI deployments. So on Linux, those are done through daemon sets, which deploy privileged containers. We don't have support for that on Windows. And so what we're doing instead is we're setting up a collection of scripts that are going to be over in one of our SIG Windows repos that will be able to handle doing things like installing Flannel for you directly on the node instead of in a daemon set. So that some of that work is going to be ongoing there, but like the key changes that we needed in KubeADM are mostly done. So the other thing I wanted to talk about is some of what we're working on, past 1.15. So I had started some integration work with getting CRI Containerd. The goal for the Containerd project was to fully support Windows with the 1.3 release. So that's still ongoing, and we're basically working together with them so that we can get a repeatable test pass up and running on TestGrid. Unfortunately, that's still not complete yet, and I'll be carrying that work on over into 16. And then, as I mentioned, we're continuing to work on the install experience. We've got the key KubeADM work going, but we're still going to make a few more scripts to make it a little bit easier to get those nodes up and running, and then continue working on the run as username support. And so, sort of beyond that, we're going to continue working on promoting features like GMSA and stuff, to beta and stable, and then working more on some of the ecosystem plugins for CNI and storage. things are still a bit early there, but we do have working plugins from multiple cloud providers. The tests for those are already visible on Test Grid, but we've got some storage plugins in the works as well. And there was actually a great presentation a few weeks ago at DockerCon in Barcelona if you want to know a little bit more about how some of those plugins are proceeding. So I think that's pretty much it for today. So if you want to join, we've got our weekly SIG meeting. We may add a separate stand-up as well to try to accommodate some additional time zones. And if you got any questions, feel free to drop by and ping us in the Slack channel or take a look at the project board if you're looking for status or areas to contribute. So that's everything I had for today. Any questions?
Looks like we have a quiet bunch today. Thank you for the update.
All right, thanks.
All right, so there appear to be no major announcements this week. So let's finish up with the shout outs. So as usual, I'm going to get a lot of names wrong and I apologize in advance. Stefan has a shout out for Jordan Liggett around the extreme number of API and CRD based reviews that he's been doing this release cycle. I've definitely seen him around a lot and I really appreciate that work. Andrew Sai Kim has a shout out for Cal around driving the IPv6 dual stack effort. Didn't quite make it into 115, but we have very good progress for 116 going forward. Tim Pepper has a shout out for Michelle L around every time there's been a release blocking test on storage, Michelle's code has been hours ahead of him. The issue's been triaged and line of sight, it's been fixed. So sounds like awesome work going on there. Lee Capelli and Vince have props to Leah Hannison for taking stellar notes at lightning speed for cluster lifecycle and cluster API meetings. That sounds awesome, makes things way more accessible for those who can't make the meeting. And lastly, I wanted to give a shout out to SIG and Trebex. I pitch in from time to time, but it's nothing compared to the work that goes on every day to just keep everything running and make sure the developers can get their jobs done. So thank you, everyone. And I believe that is it for this meeting. So thank you for joining and we'll see you in another week.